This is a view of the sort of standard or classic leg configuration on tables. You can see the apron fastened up to the underside of the table, just screwed through at an angle, and then they leave space in the corners for the leg to go in, and then there's a cross piece, and the bolt from the leg comes up through that cross piece. So that'll come, this is a table made out of ash, I don't know how long ago, a few years back. So this is standard technique how they go, and what happens is when this table here across the grain shrinks, there's nowhere really for this to go when it pushes into that. And the other thing that it will do is when you tighten this up, when you put this leg in there and you tighten that nut up, after a while this thing pushes back against and spreads the aprons out on the bottom. They can't on the top because they're fastened. And this apron here, because the grain goes longitudinally, lengthways, this apron doesn't move, but the table does because it's across the grain. It shrinks there, and if it's fastened and the table's trying to shrink and it can't, then what it tends to do is run the risk of cracks. This is early in March, and you can see the effect on this table of the drying out that I spoke of and how the end of it is cracked. If we focus in a little bit here, you can see it in the crack there. It's focusing it in out of focus, but that's because of the weather. And actually, there's another table nearby here, an old table, and you can see the same thing on it. There, see that? The boards go the opposite way in this, but you see the exact same thing. I've actually filled that with epoxy, but that's the result of drying out from the ends. There's the underside of that old antique dining table. What they did to fasten it is they cut a angle in there, and they just put the screws up through them into the underside of it. They also had a brace here, and this is the corner brace for the legs. And what they did to try to keep that from moving too much is they put, if you can see it there now, I probably can't, there's like a little squiggle nail or something they put in. So this is the bracket, this part, the middle part, and this is all one piece, and then I welded a couple of tabs on the sides. They all came pre-stamped with a slot in them, and I had not too much choice. I couldn't get the slot the size I wanted because of limitations in local supplies. And then I put this one here upside down just to make it worse. And there's more screw holes to go in it yet, but anyway. Not exactly a work of art. Okay, this is a mock-up, table mock-up to help explain how the new bracket works. So it'll go in there. I haven't drilled the holes in the bottom plate yet, but that will drill down to the underside of the table. It will screw down rather to the underside of the table. I'll put 2 or 3 screws in that. And I will also probably drill a couple more holes in this, which I'll explain when I get to it. Now, I intended the slot to be up high, but through lack of attention I installed that one upside down. And I don't have any real excuse for the quality of the welds. Just imagine that this is for prototype uses only. I don't claim to be a welder. So let me just take this apart a little bit to explain how it works, if it's not obvious. The traditional method of connecting these has the apron all fastened to the underside of the table, as I show in the example from the other table there. So this would be drilled traditionally down through, drilled and screwed down through to the underside of the table, and so would it along here. Now, just considering this piece by itself, that's no problem, because the table boards are going that way, the apron's going that way, and if you weren't have to worry about anything else, that would be fastened theoretically and stay there. Although I will say it is rather hard to drill that, pilot hole it and screw it and make it so that it pulls it in snug. I find that for some reason it tends to pull a little crooked. So there's nothing really holding this from being weak that way, except for the screws down in there and maybe a bit of glue, and depending on how good a job you do. On this side, however, it's inherently flawed, because when working from the middle of your apron that goes crossways to the grain, when it's, if you fasten it in the middle, it would be all right, but as soon as you go to either end, the table retracts, because it just seasonally, with the moisture changes, as it dries out in the dry winter air, it tends to retract, and then as you go into the damp summer months, they fill up again with moisture, and they spread. That's why there's such problems with doors that you try to make by just laminating them together like they used to try to do. So you can imagine, for the sake of arguments, that I'll take that thin slice out, and this will tell you the effect that it has when it tries to shrink and it's fastened together. So I pull that out and force these together. That's all fastened. What it'll try to do is, hard to hold everything here at once. What it'll try to do is go across there. So the effect of the shrinkage of the table is the exact same effect as if this was expanding. So if this is shrinking, it's the same effect as if that's expanding. So what it does, where it's screwed along here, if you can imagine it expanding, it tends to open up those cracks. It tends to make it crack there. As you'll see along the edges of the table sometimes, those cracks will open up. It's just because the wood goes into tension there where it's fastened with the screws, and something has to give. And on tables, because that's the end grain of it, they also tend to dry from the backside too. So they tend to, that's why wood checks in the end, it dries from the ends of them. That's why they paint them, so that they'll not dry any faster anywhere. But if it's not dry, if it's staying moisture in here and drying there, it tends to want to split on the ends anyway. And then with this apron on there and some screws in there to add some more stresses onto it. And besides that, this will also tend to push this whole assembly. And when it's fastened by your traditional block method, and that block is in there rather than it'll tend to push everything like this, and so it puts a strain on the screws that are holding this down as well. It goes under load and can cause problems along there. So the advantage of having this system here is that, well, there's several benefits that I think are going to accrue from it. I haven't actually used it yet. But this gets fastened down to the actual bed of the table, the underside of the top, and the distance between that being fastened there and an inch is not going to be enough to split anything. So it gets fastened solid. Then when this goes through here, you put a screw on the back side of it, a nut in the back side of the bolt. And then as things move, this thing here is allowed to slide on the end of it like that. It doesn't have to pull this over. So it can slide and not put any load on that. It just gets longer or shorter there. And of course that's magnified, it wouldn't move that much. And with a screw through the, screw through the slot, it helps keep this rigid, which is lacking in the original design. It keeps everything rigid and forces it to be square so it looks better. So that does that on both sides. On this side,
because the screw goes through there, it allows it to move. And it's not even necessary to put screws in all along up to the end like it is in the traditional way. It would be good to screw it in the middle, but that's not going to cause any problems. You can put a couple screws in the middle of that end apron, and you could essentially leave it open there and put screws here, and that would hold this down to the table. It would hold it square to the table, and it would allow it to move. And this system here, because it's also a slot, will be allowed to move with and it'll always be square to the bracket. Now it might be necessary, if you had a lot of movement, to go and put something like a lock washer or two in there so it could spring a little bit and allow it to go in and out. And as far as this one over here, again, this keeps this square to the table. It supports it and adds strength to it, and that's why on this on the side that's parallel to the table, I would advocate putting holes there so that that gets screwed there. There's no reason for anything to move there. So it's screwed there, it's screwed down to the table, and it provides ample support for this leg bolt. There's nothing's going to give. Now I over-designed this, so I do everything I make. It probably doesn't have to be that thick on the bottom. It could probably be a thinner piece than I made the angle out of. I just worked with what I had from the limited resources of steel supply here in town. And I don't doubt you could probably make this assembly by a bending process more. You'd have to weld something, but if this whole thing was made out of one piece, you could bend it there and bend it there, and then weld it along there, and you could make it out of lighter material, and you could make your slots better for the thinner screws. You don't need a screw as fat as that slot, although perhaps this one here is just as well that it's that thick when you look at it in the bolt. So I think it'll have multiple benefits. Anyway, that's my explanation of it. For the sake of measurements, the center of that slot is up 1 3/4 inches from the inside to the center of the slot. This piece that's left here is 3 3/4 inches, and this angle here is, I think, 2 3/4 on the outside, so it's a 2 3/4 angle, and it's a thick piece of material. I don't know what it is. I guess it's 5/16, or no, not 5/16. Not sure what it is. Anyway, it's probably overkill. These pieces are thinner. They're probably 8s, and this is probably almost. It's not a quarter. I don't think. It's like 3/16 maybe, or something like that. And the slots are. This slot actually isn't bad. It could be a little bit longer. It's about 1 inch from outside to outside. And these slots should be all up on the top part, not down there like that one. I wasn't paying attention putting it together. And they're up about the same height up, obviously, as well. But they could be thinner. They don't have to be. They don't have to be that wide a slot. Right now they're 3/8 because that's all the people had for a die for stamping it out. They don't need. This should be 3/8 in the middle, but this one here could obviously be considerably thinner than that.